Welcome back to the deep dive. So, if you've ever read a study that says, X predicts Y in human behavior, the conclusion is really only as good as the tools used to get there.
Exactly.
And today we aren't just discussing the painful and complex subject of prejudice and discrimination.
Yeah.
We're actually strapping on our methodological deep sea gear, so to speak, and diving into the incredibly sophisticated and, sometimes contentious scientific toolkit psychologists use to measure things people often want to hide.
Yeah, things like bias, automatic attitudes, those involuntary reactions.
Right.
And that's the core challenge, isn't it? How do you map the landscape of something like prejudice?
Yeah.
It's a hypothetical construct. You can't touch it. You can't see it directly.
No.
So our sources today really lay out the blueprint for how this rigorous science works.
Yeah.
The mission for us for this deep dive is to understand that necessary journey, going from a big theory about society all the way down to, well, a reliable, valid number on a piece of paper.
Or maybe a spike on a brain scan.
Or a spike on a brain scan, exactly.
Yeah. And that blueprint gives us a pretty clear structure. We're going to start with the foundation. How scientists even formulate their testable ideas in the first place. Then we jump into what seems like the absolute hardest part, the challenge of measurement. How do you make sure you're consistent and accurate?
The reliability and validity question, crucial.
Exactly. And finally, we'll look at the research strategies, from correlation to carefully controlled experiments that let psychologists confidently draw conclusions about what causes what. Okay, so let's start right at the beginning of that scientific cycle. It seems kind of intuitive that we study prejudice to, end it. But what are the specific measurable goals driving the psychological research here?
Well, the goals are really pragmatic and solution-oriented. First and foremost, the primary mission is to develop solid, evidence-based knowledge about the factors that cause people to think and behave in prejudiced ways.
So finding the ignition switch.
Finding the ignition switch, precisely. But just as important is the second goal, determining the factors that constrain or limit these behaviors. We need to identify the brake pedal, too.
Okay, so it's a system, understanding the mechanics of the problem, both how it starts and how it stops.
Exactly. And this research fits into this constantly moving, iterative cycle. Researchers don't just study prejudice in a vacuum, right?
Right.
They test existing theories to see if they hold up empirically. We're constantly refining what we think we know.
Makes sense.
And the practical, applied end goal is always the same. Once a theory is validated, once we're pretty confident it's accurate, we can use that knowledge to design effective, real-world interventions to actually reduce prejudice.
Because if you don't understand the cause, your intervention is basically just a guess.
It's a shot in the dark, yeah.
So where do these big testable ideas come from? Does a researcher just spot something happening and immediately write an article?
Well, ideas tend to originate in three main places. Maybe the easiest starting point is simple observation of everyday life. You see a social trend or an interaction and you start wondering why. The second is testing the effectiveness of existing efforts, like maybe evaluating if a diversity training program actually shifts attitudes or behavior.
Okay.
But the real engine room of this research, the major source, is existing established theories of prejudice and discrimination. These theories give us the framework for building testable predictions.
Okay, so this moves us into that kind of scientific hierarchy you hear about, the process of taking a grand theory and sort of chipping away at it until you have something concrete you can actually measure.
Right.
And we start, obviously, with the basic building blocks, variables.
A variable at its simplest is just any characteristic on which people or things can differ. Prejudice is a variable. Age, income, where you live, those are all variables. Theories then take these variables and organize our knowledge by proposing conceptual links between them. And those broad theoretical links are called postulates.
Postulates. Got it. And once we have that postulate, that high-level proposed link, then we derive the hypothesis.
Yes.
The hypothesis is the actionable statement, right? It's the concrete relationship between variables framed so it can be empirically tested. It's where the theory meets the lab, essentially.
That's a great way to put it. Let's ground this with those specific examples from the source material, because this is where the theory gets real.
Okay.
Consider the sociocultural theory of prejudice. Its postulate, its core idea, is that prejudice is fundamentally based on and transmitted by social norms.
Okay, so the hypothesis coming from that might be something like racial prejudice is observed to be stronger in specific geographic areas where those social norms are more supportive of prejudiced beliefs.
Exactly. That's something you can actually go out and measure. You can map attitudes to regional cultural acceptance, for instance.
Right.
Or Take the intergroup relations theory. This postulates that dislike of outgroups happens because groups compete for resources, land, money, political power, jobs.
Ah, so outgroup members are seen as competitors trying to get stuff the in-group wants.
Precisely.
And the hypothesis flowing from that, maybe,
Right.
prejudice will be significantly stronger between groups that see themselves as competing for limited resources compared to groups that are cooperating on a shared goal.
You got it. Again, clear comparison, clear test.
Now, this leads us to that critical, maybe the defining methodological hurdle in social psychology, bridging the abstract and the observable. Our theories rely on these things called hypothetical constructs.
Right. These are the abstract concepts like empathy, aggression, attraction, or prejudice itself. They exist conceptually, but you can't directly observe them or touch them.
So how do we define something like empathy or bias when we can't literally see it? It's not like measuring height or weight.
That's exactly why we need operational definitions. This is the concrete, directly observable representation of that abstract construct. And this step is pivotal. You have to realize that every hypothetical construct has multiple possible operational definitions.
Multiple. Okay.
Yeah, and the researcher's skill really lies in choosing the one that best captures the essence of the construct for their particular study.
So if I'm studying prejudice, my operational definition might be a score on a questionnaire.
Hmm.
Or it might be how fast someone presses a key on a computer screen in a specific task.
Exactly. Both could be valid operational definitions, but they're clearly measuring different aspects of that abstract idea of prejudice.
Right.
And once you've chosen your operational definition, then you can create your prediction. This is basically the hypothesis restated entirely in terms of those operational definitions. It moves from the realm of, philosophical ideas to the realm of hard data collection.
Okay, so if the abstract hypothesis is people high in empathy are less likely to stereotype, the concrete prediction becomes something like people with higher scores on the specific, named Davis Empathy Scale, will show lower scores on the trait checklist measure of stereotyping.
Perfect. That is the concrete link between theory and empirical testing.
Okay, so that transition from abstract idea to operational definition is critical because the measures we use, the checklist, the survey score, the reaction time, those are the operational definitions in practice.
They are.
But if we're going to invest, tons of resources into testing a theory, we need to be absolutely sure that the measure is actually worth using.
We absolutely do. When you're assessing the quality of any measure used to gauge a hypothetical construct, you have to satisfy two fundamental criteria: reliability and validity.
Reliability and validity. Heard those before.
Yeah, and if a measure fails on either one, the whole study is basically compromised.
Okay, let's unpack reliability first. I usually think of reliability as consistency. Like, does the tool give you the same reading every time?
You've got it. Reliability refers to the measure's consistency. Ideally, a reliable measure should give you essentially the same result each time it's used with the same person.
Assuming the person hasn't changed drastically.
Right. This relies on the core assumption that the characteristic we're measuring, like someone's general level of implicit bias, perhaps is relatively stable over short periods. If someone scores high on an anxiety measure on Tuesday and then very low on Wednesday and nothing significant happened in between,
Then the measure might be shaky.
exactly, the measure is likely unstable or unreliable.
Are there different ways to check for this consistency?
Yeah, the two most common ways are test-retest reliability, which is just giving the measure to the same person at two different times and seeing if the scores correlate highly.
Makes sense.
And the other is internal consistency reliability. This looks at how well different items within a single measure correlate with each other.
Okay. So if a prejudice scale has 10 questions, those 10 questions should all kind of be tapping into the same underlying attitude. They should hang together.
Precisely. They should show strong internal consistency.
Okay, now for validity. This seems like it has more moving parts, especially in social science.
It does. Validity refers to the measure's accuracy. It's asking, are we actually hitting the target we're aiming for?
Right.
And this usually have three dimensions researchers need to think about. First, does it assess the characteristic it's intended to assess? Is it measuring prejudice or something else?
Okay.
Second, does it assess all the relevant aspects of that characteristic? This is often called construct validity. Are we capturing the whole picture of prejudice?
Okay.
And maybe the toughest challenge, does it assess only that characteristic and not some confounding factor? Is it pure?
So if I create a survey to measure generalized anxiety and someone scores high on it,
Right.
Is that score just because of their anxiety,
Mm,
or could it actually be capturing their level of, say, neuroticism, or maybe they just didn't sleep well? That would be a failure of validity.
that's a perfect example. And in the study of prejudice, there are specific massive threats to validity. The primary one is the social desirability response bias.
Ah, yes, the tendency people have to answer sensitive questions in a way they think makes them look good.
Or politically correct, or just conforming to what they think society expects.
Yeah.
Exactly. And it's not always malicious. It can be kind of an involuntary self-presentation thing.
Sure.
But if a measure is supposed to capture genuine negative feelings toward a group, and the respondent knows the socially acceptable answer is, I have no negative feelings,
Then the data gets corrupted.
completely.
Yeah.
It stops measuring genuine prejudice and starts measuring the desire for social acceptance, or maybe just awareness of social norms. This bias significantly reduces the validity of any straightforward self-report measure.
Which forces psychologists to get much more creative and indirect with their tools.
Absolutely, it's a constant challenge.
Okay, let's explore that necessary toolkit then. We have to start with the most traditional method, the easiest, but also the most vulnerable one, self-report measures.
Yeah, self-report is really the foundation. It involves asking people directly about their attitudes, opinions, and behaviors. It's still the most common initial method, mainly because it's efficient.
But you have to take the results with a grain of salt.
A big grain of salt, precisely because of that social filter we just discussed.
So how do researchers operationalize stereotypes using this self-report method?
Well, they typically use two main formats. The first is checklists. Respondents get a specific list of traits, maybe lazy, intelligent, aggressive, hardworking, things like that.
Okay.
And they're asked to check off which traits they believe describe a specific group, like accountants or artists or a racial group.
Right. And the second format.
The second uses probability ratings. Here, you ask respondents to estimate the percentage likelihood that members of a group possess certain characteristics, like what percentage of Group X members are college educated.
Ah, okay. So that gives more of a numerical estimate of stereotype strength.
Exactly.
And for measuring prejudice itself, the feeling or attitude, we have the classic attitude questionnaires.
Yes. These usually require respondents to rate their agreement or disagreement with statements about an outgroup. Things like, I would feel uncomfortable if a member of Group X moved next door.
But as we noted, these direct measures are super vulnerable to social desirability bias.
Highly vulnerable, which led researchers to develop more subtle self-report measures designed to kind of bypass that direct filter.
Can you give an example of a subtle question? How does that work?
Sure, so instead of asking directly, do you dislike Group X, a subtle measure might ask something like, to what extent do you feel resentment that Group X seems to be getting more resources than they deserve?
Ah, okay. Framing it as resentment or fairness.
Or they might assess the perception that other groups are violating important values, like the value of hard work or traditional family structures. This taps into prejudice as an underlying sense of threat or grievance, which people might be more willing to report than pure, simple dislike.
Interesting. And self-report is also used to assess discriminatory behavior, right? Or at least the intention to discriminate.
Absolutely.
Yeah.
Researchers assess how people say they behave or how they think they would respond in various scenarios involving different groups. The classic historical example here is Bogartis' social distance scale from way back in 1928. It's a fascinating attempt to map prejudice based on, well, desired proximity.
Social distance. How far did that scale actually range? What kinds of questions did it ask?
It was typically a 7-point scale.
Yeah.
It asked respondents how closely they'd be willing to associate with members of a particular group. And the range was pretty stark.
Yeah.
It went from step 1, like accepting them as a close relative by marriage, all the way through steps like accepting them as a neighbor or a coworker, down to the final step, step 7, wanting to exclude them from your country entirely.
Wow. That really provides a quantifiable map of where someone draws their lines of acceptance.
It does. Very direct.
So despite these clear weaknesses, especially the social desirability bias, what keeps self-report in the researcher's toolkit? Why not just abandon it?
Well, it's sheer efficiency and accessibility, really. It's still the most straightforward way to capture conscious, stated opinions.
Okay.
It's relatively cheap, it's easy to administer to large groups, requires no special equipment, and you can cover a huge range of topics across many participants at once. But because it's so easy for people to conceal their true attitudes, researchers simply must use more objective measures alongside it, or instead of it, depending on the question.
Okay, so that brings us into the realm of the involuntary, the things people can't easily control. Starting with, Unobtrusive and physiological measures. What are unobtrusive measures?
Unobtrusive measures focus on behavior that people don't realize is being assessed as part of the study, or that seems unrelated to prejudice.
Like what?
Well, examples include observing nonverbal cues, like how far a person physically stands or sits from someone they're interacting with, particularly if that person is from an outgroup, measuring physical distance,
Ah, okay. That seems subtle.
or measuring helping behavior in a staged scenario. Researchers might set up a situation where someone needs help. Maybe they drop some books and observe how quickly, or even if a participant helps a member of an outgroup compared to an in-group member.
The key is the participant doesn't connect their behavior to a prejudice assessment.
Exactly. They don't perceive their distance or their helping behavior as a test of their prejudice.
Okay, then we move to the really involuntary physical reactions, the physiological measures.
Right. These assess changes in the body's automatic responses to a stimulus. We're talking about basic metrics like heart rate, blood pressure, skin conductance, how much you sweat, or even subtle shifts in voice pitch when exposed to images or stimuli related to different groups.
And the big technological leap here is brain imaging, like fMRI.
Exactly. Functional magnetic resonance imaging, which measures changes in blood flow in the brain, indicating neural activity.
So what specifically does measuring someone's blood pressure spiking or their eye blink rate changing tell us about their attitude toward a group?
Primarily, it indicates the intensity of the emotional response. And crucially, some sophisticated measures can sometimes distinguish between generally positive and generally negative emotional reactions, the valence.
Okay, intensity and valence.
Yeah. And the huge advantage of this method is that most physiological reactions are simply beyond voluntary conscious control. You can rely on a survey.
But you can't tell your heart rate to calm down.
Exactly. You can't easily tell your body to stop sweating or your voice to stop shaking if you're faced with a stimulus that triggers anxiety or anger or some other strong emotion.
But wait, if someone's heart rate spikes in the lab, how do we know if they're feeling prejudice? Couldn't they just be nervous about being in an fMRI machine, or maybe they just had too much coffee beforehand?
That's the critical limitation. You've hit it exactly.
Yeah.
The equipment is expensive. It requires specialized training to use and interpret.
Yeah.
But more importantly, while it can show the intensity and maybe the general positive and negative valence, it often cannot distinguish between specific emotions.
Right.
A rapid heart rate could be fear, it could be excitement, it could be anger, it could just be arousal or surprise. That ambiguity is why researchers often need to pair these physiological measures with other types of measures, maybe more cognitive ones.
Okay, so it seems we can only get so much information from just heart rate or sweat. When we want to understand why the body reacts, that seems to be when we need to look at the brain itself through cognitive neuroscience.
Absolutely. Cognitive neuroscience specifically studies how the structures and processes of the brain influence thought, emotion, and behavior.
Makes sense.
And within the study prejudice, a lot of the research naturally gravitates toward the amygdala. It's a small, almond-shaped structure deep in the temporal lobe.
And it's often associated with processing emotional stuff, right?
Yeah.
Especially threat detection and fear.
That's the common association, yes.
Yep.
It plays a key role in processing emotional salience, things that stand out emotionally, which often includes potential threats or fear responses.
The sources you shared cited some really fascinating findings here. I remember reading about the Ronquillo and Phelps studies. They seem to offer some crucial nuance to the amygdala's role. What did they find when showing white participants different faces?
Well, Ronquillo and colleagues, back in 2007, initially found a really interesting pattern. White participants showed increased amygdala activity not only in response to black faces, as perhaps expected based on simple group difference ideas, but also in response to dark-skinned white faces, compared to light-skinned white faces.
Oh, interesting. So it wasn't just about race, per se.
It suggested the amygdala might be reacting to something like novelty or ambiguity in categorization, or maybe even perceived deviation from a prototypical norm, rather than purely race. It seems to flag things that are different or emotionally salient.
But then the Phelps study from 2000 offered a massive methodological nuance, didn't it? It showed the response wasn't purely tribal or automatic in a fixed way.
That's the key insight from Phelps and her team. While they did find greater amygdala activation on average, when white participants viewed pictures of unfamiliar black faces, the expected finding based on some theories.
Yeah.
That heightened response was not found when the pictures were of well-known, well-liked black individuals. Think prominent public figures, celebrities, people the participants likely had positive associations with.
Wow, okay, that feels like a fundamental turning point. It suggests the automatic, maybe biological reaction isn't fixed. It seems highly susceptible to individual positive association, potentially overriding a general group categorization.
Exactly. The response isn't rigidly set. It appears malleable based on personal experience and affect the feelings associated with the individual.
That's huge.
However, we do need to inject a methodological note of caution when you talk about interpreting fMRI data like this. It's the problem of reverse inference.
Reverse inference, what's that?
Well, it's when we see a brain area light up, like the amygdala,
Hmm.
and we automatically infer that the person must be experiencing a specific psychological state, like fear or threat.
Okay.
But the amygdala, like most brain regions, is involved in many different processes.
Hmm.
Positive emotions, novelty detection, general arousal. So inferring a specific psychological state like prejudice or fear purely from that brain activity is a major leap. It's a big challenge in cognitive neuroscience that researchers have to be really careful about.
That's a really important detail for our listeners to keep in mind. Okay, let's shift now to the final and probably most famous category of indirect measurement, implicit cognition measures.
Right. These are designed specifically to get around conscious control by assessing the degree to which different concepts are associated with one another in memory. They aim to capture responses made without conscious thought or deliberation.
So we're essentially trying to map the automatic connections in the brain, like how strong is the unconscious link between a particular group and a negative trait versus a positive trait.
Exactly. For instance, researchers might compare the strength of association between, say, a stigmatized group like fat people and unpleasant words versus the strength of association between a preferred group like slim people and pleasant words. A larger difference, showing a stronger negative association for the stigmatized group, is taken to indicate a higher degree of implicit prejudice or bias.
And the undisputed champion, the most well-known tool in this domain, is the implicit association test, or IAT. How does the IAT actually work? What's the mechanism?
Okay, so the IAT works by measuring something called response competition. The task requires the participant to very rapidly categorize stimuli. These could be faces, names, or words into 4 categories using only 2 response keys on a keyboard.
4 categories, 2 keys. Okay.
Yeah, so they have to perform blocks of trials where the categories are congruent, meaning they align with common stereotypes or associations, like pairing good words and my in-group faces on the same response key.
Right.
And then they do blocks where the categories are incongruent, like pairing bad words and my in-group faces on the same key, or good words and an out-group on the same key.
Ah, okay. And the trick is, if you already have a strong habitual unconscious link between, say, my group and good,
Yeah.
it's super easy and fast to hit that shared key in the congruent block.
Correct. The stronger the habitual automatic response, like maybe associating this stigmatized group with negative concepts, the longer it takes for the person to suppress that automatic impulse and make the opposing less habitual categorization in the incongruent block.
So forcing yourself to pair the stigmatized group with positive words takes slightly longer if you have a strong negative association.
Exactly. The difference in reaction time between the congruent easy condition and the incongruent harder condition reveals the strength of that implicit association. You essentially cannot fake a faster reaction time when the task conflicts with your automatic associations.
The clear advantage seems to be the near elimination of that social desirability bias we talked about.
That's the primary goal, yes.
But the IAT is also subject to some pretty intense debate, isn't it? What's its main limitation for researchers trying to interpret the scores?
Well, a key limitation lies in its interpretation. The IAT is fundamentally a measure of relative preference, not absolute prejudice.
Relative preference.
Meaning, a high IAT score showing, say, a preference for thin people over fat people doesn't necessarily tell us if you strongly dislike fat people or if you simply really, really like thin people, or maybe a bit of both. It only shows that one concept is more positively evaluated compared to the other in your mind. It's a comparison score, not an absolute measure of negativity.
Okay, that's a crucial distinction. And this brings us to maybe the biggest paradox, or at least puzzle, in the study of bias. The notoriously low correlation often found between self-report measures, what people say, and these newer implicit or physiological measures, what their automatic responses suggest. If they're both supposed to be measuring prejudice, why don't the scores line up better?
This is perhaps one of the most important methodological insights to emerge over the last couple of decades. The low correlation exists, most researchers now believe, because they're actually measuring different aspects of prejudice or different types of attitudes.
Okay, different things.
Essentially, yes. Self-report measures tend to capture the controllable, conscious expression of prejudice, the attitude you admit to, the one you consciously endorse and think about. And these scores are often pretty good predictors of more deliberative, planned behavior, like voting decisions or policy support.
Okay, the conscious controlled stuff.
Yeah.
And the physiological and implicit measures.
They seem to capture the automatic, habitual, often uncontrollable responses, the associations that exist deep in your memory structure, maybe outside of your conscious awareness or control, independent of your desire to look good.
Right.
And these implicit scores are often better predictors of more spontaneous, immediate, maybe nonverbal behavior. Things like eye contact, how far you sit from someone, microexpressions, or immediate snap judgments in ambiguous situations.
So the best practice then, it sounds like, is not to pick one side as the true measure, but to actually use both measures of controllable and uncontrollable expression, because they relate to different kinds of real-world behaviors.
Absolutely. You need the full spectrum. The scientific confidence in your findings increases dramatically when you use multiple, diverse types of measures. Strengths in one domain, like the efficiency of self-report, can compensate for limitations in another, like the ambiguity of physiological arousal. Using both provides a far more valid and comprehensive assessment of the overall hypothetical construct.
Okay, so we've formulated the hypothesis, we've wrestled with the challenges of measurement, and selected our operational definitions, our specific measures. Now, we actually need a strategy for collecting the data and drawing meaningful conclusions. The sources lay out about 5 main research strategies we should cover.
That's right. Correlational studies, experiments, ethnographic studies, content analysis, and meta-analysis. And honestly, understanding the crucial difference between the first two, correlation and experimentation, is absolutely fundamental if you want to critically evaluate almost any study on social behavior.
Okay, let's start with probably the most common approach you see in social science, correlational studies.
Right. Correlational research, at its core, simply involves measuring two or more variables as they naturally exist, and then looking for a statistical or mathematical relationship between them. Surveys are the classic tool here.
Just asking people questions and seeing how the answers relate.
Pretty much. Surveys are widely used to gather data on pre-existing variables like attitudes, beliefs, personality traits, reported behaviors, demographics, and so on.
And when you're running surveys, or any correlational study really, the crucial first step seems to be sampling. How do researchers try to ensure their sample can actually speak for the whole population they're interested in?
Well, the gold standard, the ideal method, is probability sampling. This method uses randomized selection techniques like drawing names out of a hat digitally to create what's essentially a scale model of the population of interest.
Okay.
By guaranteeing that every single person in the defined population has a known non-zero chance of being included in the sample, we can have pretty high confidence that the relationships we find in the sample accurately reflect what's happening in the broader population.
But the reality is that kind of sampling is extremely difficult and often very expensive to do properly.
It really is, which is why many researchers, especially in psychology, often have to rely on convenience sampling.
Which is
Basically collecting data from whomever is easily available, often university students, because they're right there.
the famous Psych 101 pool.
Exactly. Or people recruited through online platforms or members of a specific community group that's easy to access. This is fast and cheap, but it comes with a big risk.
Yeah.
You have absolutely no guarantee that this easily collected sample actually represents the target population you want to generalize to. So you need to be significantly cautious when interpreting and applying findings from convenience samples.
Okay, makes sense. So once the data is collected, whether from a probability or convenience sample, we look at the correlation coefficient, usually represented by the letter R.
Right. This is the statistic that describes both the strength and the direction of the linear relationship between two variables. It ranges from -1, omega 1, to +1, +1.
And 0 means?
0 means absolutely no linear relationship between the two variables.
Okay. And if the coefficient is positive, say, plus 0.7?
The positive correlation means that as scores on one variable go up, scores on the other variable tend to go up as well. Like maybe income and years of education often show a positive correlation.
Right. And if the correlation is negative, say, negative zero point
A
0.6.
negative correlation means that as scores on one variable go up, scores on the other variable tend to go down. For example, maybe increased exposure to diverse groups is negatively correlated with expressed prejudice scores.
Okay. But now we get to the big, crucial mantra that must always be repeated. Correlation does not equal causality.
Say it again, it's so important.
Why, specifically, can correlational research not determine cause and effect?
Okay, because it fails to meet two of the three necessary criteria for establishing causality. First, you need covariation. The variables must actually be related. They have to vary together. Correlation meets this one. If arrow 0, there's no relationship to even discuss. But second, you need time precedence of the cause. The presumed cause must demonstrably occur before the presumed effect. In most correlational studies, especially surveys collecting data at one point in time, we simply can't tell which variable came first. Did watching violent TV lead to aggression, or did aggressive kids choose to watch violent TV?
The chicken and egg problem.
Exactly. And the third criterion, the most persistent challenge for correlational studies, is ruling out alternative explanations. This is often called the third variable problem.
Ah, okay. Explain the third variable problem.
Right. It's possible that a third, unmeasured variable is actually causing the observed correlation between the two variables you did measure, say, x and y.
So X doesn't cause Y, and Y doesn't cause X.
But some other factor, z, causes both x and y, creating a spurious correlation between them. For instance, imagine a correlational study finds a strong positive relationship between ice cream sales, x, and crime rates, y.
Okay. Seems weird.
Does eating ice cream cause crime? Probably not. Does committing crime make you crave ice cream? Unlikely.
So what's the third variable?
The obvious third variable is hot weather, z. Hot weather causes people to buy more ice cream, z causes x. And hot weather also tends to correlate with more people being outdoors, maybe more irritability, leading to higher crime rates. Z also causes y. The weather explains the correlation.
Got it. So in a correlational study, you can almost never rule out all possible third variables.
It's incredibly difficult, which is why, to definitively determine cause and effect, we absolutely must move to the experiment.
Right. The experiment is considered the gold standard for determining cause because researchers actively manipulate variables to ensure those three criteria for causality are met: covariation, time precedence, and no alternative explanation.
Exactly. In an experiment, we define the independent variable, or IV. This is the proposed cause, the thing the researcher systematically changes or manipulates by creating different conditions or groups.
Okay.
And then we define the dependent variable, or DV. This is the proposed effect, the outcome variable that the researcher measures after the manipulation to see if it was affected by the IV.
And the key is random assignment.
Crucial. By randomly assigning participants to the different conditions of the independent variable, researchers aim to make the groups equivalent on all other factors before the manipulation. And by controlling all other extraneous factors during the experiment, any difference observed in the dependent variable between the groups can be confidently attributed to the manipulation of the independent variable. It isolates the cause.
We generally see experiments run in two main settings, right? The lab and the field. What are the trade-offs there?
Yeah. We have laboratory experiments conducted in highly controlled, often artificial settings. Their strength is high internal validity. You have maximum control over extraneous variables, making it easier to rule out alternative explanations and be confident about causality.
But the downside?
The cost is often low external validity or high artificiality. Behavior observed in a sterile lab might not accurately reflect how people behave in the complex real world. Conversely, field experiments are carried out in natural, real-world environments, like a workplace, a school, or a public space. They offer high naturalism, high external validity, because you're studying behavior where it actually happens.
But you lose some control.
Exactly.
Yeah.
The researcher sacrifices some degree of control over extraneous variables, making it harder to completely eliminate every single competing factor or alternative explanation. There's always a trade-off between control and realism.
And one more crucial point about experiments. We need to remember the distinction between a truly manipulated variable and what's called an individual difference variable that might be included in the study.
Yes, this is important. Individual difference variables are pre-existing characteristics of the participants that the researcher measures but does not manipulate. Things like age, gender, personality traits, pre-existing attitudes, socioeconomic status.
So even within a highly controlled experiment.
Right, even within an experiment, you cannot draw causal conclusions about the effects of these non-manipulated individual difference variables. You can see if, say, men and women responded differently to the manipulation, but you can't say gender caused the difference in the same way the manipulation did. Only the variables the researcher actively controlled and varied can be inferred as the cause.
Okay, super important distinction. Now, moving beyond the purely quantitative approaches of correlation and experiment, psychologists also use qualitative and synthesis strategies. Tell us briefly about ethnographic studies.
Ethnographic studies rely primarily on qualitative data. This involves deep immersion in a setting, using methods like participant observation, detailed field notes, and in-depth interviews. The goal is to understand how people experience and interpret events within their natural daily lives from their own perspective.
So the focus is on deep, contextual understanding, not necessarily statistical averages.
Exactly. It prioritizes naturalism and aims to capture the richness and complexity of lived experience. It sacrifices the control of an experiment for that depth of understanding.
And content analysis, what's that?
This strategy involves systematically studying the products people create. This could be documents, letters, diaries, photographs, news articles, social media posts, advertisements, works of art, anything people produce.
And what are you looking for?
Researchers analyze this content to identify relevant themes, patterns, biases, or changes over time. For example, someone might do a content analysis of how different ethnic groups are portrayed in children's television shows from the 1970s versus today to understand shifts in stereotyping.
Okay. And finally, the strategy that kind of brings everything together, meta-analysis.
Yes, meta-analysis is a tremendously powerful statistical tool, especially in areas with lots of existing research. It involves statistically combining the results from multiple independent studies that have all investigated the same basic research question or relationship.
So you gather all the studies on, say, the effectiveness of diversity training.
Exactly. You find all the relevant studies, extract their statistical results, and then use specialized statistical techniques to calculate an average effect size or relationship strength across all those studies combined.
And why is that average better?
That average result is considered a far more accurate and stable estimate of the true relationship in the population than the result from any single study, which might be affected by sampling quirks or specific methodological choices. Meta-analysis brilliantly offsets the limitations and potential biases of individual studies by looking at the big picture.
So the major takeaway from looking at all these different strategies, correlation, experiment, ethnography, content analysis, meta-analysis, is that true scientific confidence in a conclusion comes when findings from different strategies all point in the same direction.
Absolutely. That convergence of evidence from multiple methods, each with different strengths and weaknesses, is the most powerful form of verification in science. If a correlational study finds a link, a lab experiment confirms causality, and an ethnographic study provides real-world context, all pointing the same way, then you can be much more confident in the finding. #TagV, drawing conclusions and applying theory. Okay, so after this enormous effort formulating the question, choosing measures, executing a research strategy, collecting data, the really critical work of interpretation begins. Did the data support the hypotheses? And maybe more importantly, what do the findings actually mean for the underlying theory?
Right. For the quantitative data, the numbers from the survey, the IAT reaction times, the physiological readings, researchers use statistical analysis. This basically determine how likely it is that the observed outcome, the pattern in the numbers, occurred purely by chance. If that probability is very low, usually less than 5%, we declare the finding statistically significant. And that suggests it might genuinely support the hypothesis rather than just being a random fluke.
Right. And for the qualitative data, the themes identified in ethnographic interviews or the patterns found in content analysis, researchers have to look for consistent patterns of responses or behaviors that either support or seem to refute their hypotheses. They're looking for recurring themes and narratives rather than probability scores.
But interpreting those findings, whether quantitative or qualitative, it sounds messy. It's not like a machine just spits out a single objective truth, right?
No, rarely, if ever, is it a single truth. Research findings, especially in social science, often have multiple plausible explanations. And, let's be honest, interpreting that data is inevitably influenced, at least to some degree, by the researchers themselves.
How so?
Well, their theoretical orientations, the theories they already believe in, their personal backgrounds, their own values and experiences. These things are always going to subtly color how they frame the research question, choose measures, analyze data, and ultimately interpret the findings.
So need to be aware of potential bias in the interpretation itself.
Absolutely.
Yeah.
And we also just have to remember that social phenomena are incredibly complex. They can absolutely have more than one cause and therefore more than one valid explanation or interpretation. It's usually not just one simple thing.
Okay, so once an interpretation is made, the result is never really considered final or solid until it has been verified through replication, right?
Replication is absolutely essential for building confidence in a scientific finding. We generally talk about two types. Exact replication, sometimes called direct replication, is the rigorous process of redoing the original study using the precise same procedures, measures, stimuli, everything to see if the original finding holds up.
Just trying to get the same result again.
Exactly. And the other type, which is arguably even more important for building robust theories, is conceptual replication.
Okay, what's that?
This means redoing the study, but intentionally introducing specific changes in the procedures. Maybe you use different operational definitions for the same underlying construct, or you test the hypothesis in a different setting, lab versus field, or you use a different type of sample, students versus community members.
The goal being?
The ultimate goal of both types of replication is to establish generalizability. We want to ensure that the basic finding, the conclusion about the hypothesis, remains similar, regardless of the specific way the study was conducted, the specific sample used, or the specific measurement tools employed. Does the finding hold true across different contexts?
Makes sense. You want something robust.
Exactly. And this whole rigorous process of testing, interpreting, and verifying through replication brings us right back full circle to theory and application.
How so?
Well, if the findings consistently confirm the hypotheses across different research strategies and through successful replications, then our confidence in the accuracy and usefulness of the underlying theory increases exponentially.
And if the results are inconsistent or fail to replicate?
Then the theory must be revised. Maybe it's only true under certain conditions, or maybe it's just plain wrong and needs to be significantly modified or perhaps even scrapped entirely in favor of a better explanation.
And it's that hard-won confidence in a theory that allows psychologists to finally transition to the applied world.
Precisely. That confidence is what allows researchers and practitioners to apply the theory to real life, for instance, by designing effective, theoretically sound interventions aimed at reducing prejudice and discrimination in schools, workplaces, or communities.
Based on what the research suggests actually works.
Exactly. And then ideally, the final step is testing that application itself. Research is then conducted again to evaluate the effectiveness of that intervention. Did it actually work in the real world? And the results of that evaluation are fed back into the system to further improve and refine the underlying theory.
So it really is a continuous self-correcting engine. Theory informs application, application tests theory, and the whole cycle keeps moving forward.
That's the ideal scientific process, yes.
Yeah.
It's all about building more accurate and useful knowledge over time. #outro.
Wow. Okay, this deep dive really puts into perspective the sheer methodological weight, the complexity involved in scientifically studying something like bias. Researchers are faced with this huge task of translating an abstract, kind of slippery concept like prejudice into a tangible, testable score.
Yeah, whether that's done via the maybe blunt instrument of a checklist,
Right.
or the incredible technological complexity of an fMRI scan, or the sort of ingenious mechanism of timing a button press on the IAT.
And the complexity, as we discussed, is really driven by the reality that we need this diverse suite of tools. We need self-report for the controllable, conscious responses people give, and we need those implicit and physiological measures for the automatic, harder-to-control responses.
Exactly.
Yeah.
And hopefully you, the informed listener, now understand that if you read about a study that only relies on what people say they believe or feel,
Yeah.
it's likely missing a huge piece of the puzzle. It's missing those automatic habitual associations that research increasingly shows still govern a lot of our immediate spontaneous behavior, especially nonverbal cues.
And by understanding the mechanisms behind these methods, the difference between test-retest and construct validity, or the critical constraints of correlation versus the power of experimental causality, you really gain a powerful lens, a lens for critically evaluating any finding about social behavior you encounter, whether it's in the news, a report, or even just conversation.
Absolutely. And that understanding leads us directly to our final provocative thought for you to consider, drawing straight from those neuroscience findings we discussed earlier.
Okay.
Remember, the data suggested that those automatic unconscious responses, like the amygdala activation, were not triggered when participants viewed pictures of well-liked familiar outgroup members.
Right. The positive associations seem to override the group category.
Exactly. Which implies that the automatic reaction isn't necessarily fixed based on a simple category label, but seems susceptible to positive personal association and familiarity. So, if further research confirms this pattern is generalizable, what does that tell us? What are the most effective, scalable, real-world interventions we could design?
Interventions that leverage things like positive exposure, or highlighting shared goals, or promoting individuating information.
Precisely. Interventions designed specifically to shift those ingrained automatic negative associations into more positive habitual ones, maybe on a massive societal scale.
Yeah.
That seems like the immediate, critical, real-world challenge that validated psychological theory must now try to address.
That is a fascinating and, frankly, hopeful question to end on. That's all the time we have for this deep dive into the intricate science of mapping social bias. Until next time.